Hello dear students of class 9, how are you today? You're doing excellent, I hope so. In today's video, we are going to solve and practice few mixed numericals from the chapter motion. So are you ready? I hope so. So without any further ado, let's get started. So on your screen, you can see here 4 questions of the day. You can take your time to read the question yourself, and if you have not read these questions before or not done this question before, you can take 20 minutes of your time and do the solution and then come back to see the solution here. Okay, so I hope you have done. Now let's jump into the solution. The question number 1 is what do you mean by uniform and non-uniform speed? Okay, or uniform motion and non-uniform motion, right? So this question you can answer in 2 ways. You can either write in paragraphs, which I avoid generally. I want you to write the answer in points. So what we can do is we can make 2 columns, one for the uniform motion and other for the non-uniform motion. Well, when I say uniform speed and non-uniform speed, it's very simple. When we say uniform speed, basically it means constant speed. An object moving with constant speed is said to be in a uniform motion, and an object moving with varying speed or non-constant speed or changing speed, that is all said to be non-uniform motion. Well children, this same definition can be expressed in 2 ways, because you know speed is expressed as 2 quantity, that is distance by time, right? So we can use distance and time to express the same concept. So here the definition would be, if an object covers equal distance in equal interval of time. If time interval is same and the object is covering equal distance, right, then the object would be said to be in a uniform motion. And for non-uniform motion, if we keep the time interval same and the object is covering unequal distance, right, in that case it would be said to be in a non-uniform motion, right? So this is uniform motion and this is non-uniform motion, because the speed is sometimes changing, sometimes increasing and sometimes slowing down. Okay, this was an easy question. So let's get into the second question. It's my favorite actually. The question number 2 is based on average speed. Now the question says a car moves from A to B. So I am considering this point as A and this is point B at a constant speed. Just now we have discussed what is constant speed, that is uniform speed of 60 km per hour. So here the object is moving with 60 km per hour and returns to A. So from B it is returning, and it is returning at a speed of 40 km per hour. That's it, no more information given, and we are supposed to calculate average speed. Now the moment children read this question in class 9, they like, how can we solve? We know the formula, that is average speed is equals to, I'll write over here, average speed is equals to total distance covered by total time taken. So you write here, let's say this is d1 plus d2. I am writing d1 plus d2 because there are 2 intervals, A to B and B to A. So d1 plus d2 divided by t1 plus t2. So this is the formula known to all the children. Now the moment they see this, they are like, so time is not given. In fact, distance is also not given, right? So how to go about this question? Well, one thing to note over here is to find d1, d2, t1, t2. Let us assume, okay, let us first of all understand the question here. The object, this car goes from A to B, right, and then it returns from B to A. So what do we understand basically is that the car is covering equal distance, right? So here I am assuming the distance to be like, you know, x kilometer or x, let's say. Let the distance is equals to x, this one from A to B, this distance is x. So while returning again, the car would be covering the same distance, right? It would be covering x again, right? So we have got basically distance. This is x and x. Now we can find time over here, right? Since the speed is given, so while going up from A to B, what will be the time? If I am calling it as t1, so t1 will be equals to distance by speed, right? Distance by speed, and distance we have assumed as x, and the speed while going from A to B is 60 kilometers, so this is x by 60. So this is the time, x by 60. And similarly, while coming back from B, so if I call it as t2, so while returning, the speed will be distance by time again, the distance by speed, sorry, and this will be x, which is the distance, divided by the speed, that is 40, right? So this is x by 60 and x by 40. These two quantities represents time, and distance is x and x. So from here we can actually see distance as x and this is as x, and time will be x by 60 plus x by 40. We just need to solve this and we would get the answer, right? So I hope you all are good with your calculations over here, and let's try the calculation in the next page. So x plus x, let us do over here, x plus x divided by x plus 60 plus x by 40. There are many ways to do it. So what I will do is I'll just add x plus x as 2x, and I'll take the LCM of 60 and 40. So LCM of 60 and 40 will be 120. So this will give me like 3 into x, that will be, sorry, this is 2 into x, and that will be 2x plus 3 into x, that is 3x. So if I solve over here, I am getting this as 2x divided by 5x by 120. Remember, we assumed the distance to be x, right? We assumed the distance to be x, and now you can see that x and x will be cancelled out even. So I'll do that in the next step. I'll simplify this even more. This is 2x divided by, sorry, this is 2x, I'll not do anything below 2x. This is 2x multiplied by this division sign I am converting into multiplication sign, right? So you know, if I convert this division into multiplication, we have to do the reciprocal of the denominator. So this will become 120 divided by 5x, and now you can simply cancel x and x. So this is basically 2 into 120, 2 into 120 divided by 5. So you can multiply over here. This will be like 5 times 2 and then 2 0, that is 25. Am I right? No, this is 24. Let's correct it. This is 24, and the answer would be 48, and the answer, since the unit is kilometer per hour, the answer would be 48 kilometer per hour. Now this question is not very intuitive because children, they do not understand that we have to assume x. Well, you have to, because only one information is given, and if x and x is getting cancelled out in the solution, what does it mean? You need to think over here. Why we could assume it as x? Can we assume it as 100 or something and then solve? Yes, you can do it. But why? The question is why? Because here you see the solution is independent of x, right? X and x get cancelled out. So if I take 100 and 100, again that 100 and 100 would have got cancelled out. So it means that the answer is not dependent on the distance. Why? The distance covered is actually equal. So if distance covered is equal in the two intervals, we can find the solution in an easy way. Well, the children again making the mistake in this question is sometimes they blindly write the speed is 60 and 40, and what they do is they take the average of 60 plus 40, like this 60 plus 40 by 2, this is 100 by 2, and that is 50 km per hour. This is what is the intuitive answer given by most of the students, but this is absolutely wrong. And when this answer will be correct, I have discussed this in the previous video, so you can watch that video also. When this solution 60 plus 40 will be 60 plus 40 by 2 will be correct, but in this case the answer is 48 km per hour. Now in this video I am going to give you a short trick to remember this particular question and how you can solve it, right? So from this particular question, what you see, the time interval, the distance, as the object is going from A to B and is returning from B, it is covering same distance, right? Whatever distance it is going like this, it is returning the same distance. So when you have got same distance covered in the 2 time interval, then we can directly use the formula of speed as 2 times x and y, which is the speed while going up and down in the 2 intervals, and x plus y, we can just add the speed. So if I take this formula to calculate the answer, I would be getting over here as 2 multiplied by x is over here 60. So this is 60 multiplied by y is 40. So I'll write here 40 divided by 60 plus 40. So from here we are supposed to get 48. Let us see how. So this is 2 into, I'm not multiplying right now, I'll keep it as it is, and then I'm getting 100 over here. So now we can cancel some zeros, so this 0 get cancelled out. This is 2 into 6, 12 times 4 is 48 km per hour, right? So this is the answer. So it's not that the object has to always return like A to B and B to A. It can go from A to B and B to C as well, but if the distance is same, then again the same formula could be used. I hope you are getting what I said right now, okay? So that's the solution of question number 2. Now let's get to the question number 3. And the question number 3 is an easy question based on 3 equations of motion. So I'll just start reading out the question, and as I've told you, before you start reading any question based on 3 equations of motion, if you can figure out, then you can start writing in the beginning all the given information like this: given u, v, a, t and s. This is the problem solving technique you all must follow for solving any numerical based on 3 questions. You must write the information in the table like this, and then take your pen and pencil, and when you read the question, start underlining as I do it. A train starting from rest. This is a key word, starting from rest, which means that the initial speed is 0. Sometimes you find that the information will not be given in numbers. So there are certain keywords like this, right? From where you have to catch that the initial speed is 0. So a train starting from rest moves on a straight track, fine. It has an acceleration of 2 meter per second square. There is a printing mistake over here, of 2 meter per second square. So A is 2 meter per second square. The question is, calculate the distance traveled by it in 10 seconds. We need to calculate here S, and of course time is given here is in 10 seconds. So I'll take it as 10 seconds. So as I've told you, in this particular question we got 3 information already: u, v, a and t. It means that we can calculate the other 2 values when asked, okay? We will be calculating v in meter per second and s in meter. You must mention so that you can convert if required, okay? Now here we have to find v and s. The first question, it says distance. We can start finding. Of course we can use the second equation directly. Why? U, a and t is known to us, so we can start writing the solution using second equation of motion. Using second equation of motion, let's write the equation first, okay? Do not jump into putting the values. This is S is equals to ut plus half a t square. This implies we are calculating S, so S will be equals to u is 0 multiplied by t, time is 10 seconds, plus half a is 2 and t is 10, so this is multiplied by 10 square. So here I often see children making mistake and adding 10 and 1 by 2. You are in class 9, dear, please take care of the board mass. You are not supposed to make such silly mistakes in class 9. This is 0, 10 into 0 is 0, and then half 1, this 2 and 2 can be cancelled out, and 10 square is 100. This means that the train covers basically 100 meters in 10 seconds. Okay, that's the answer of this first part. Now the question number 2 is find the final speed achieved by the train in 10 seconds. So usually what happened over here, the train started from speed 0. I did not put that in the diagram, so I am writing again. So initial speed u was 0, right, and the train started moving, right, and it moved for 100 meter. So it moved somewhere like from here, it must have moved 100 meters and it attained a certain speed. So this is 100 meter it moved, right, and then it got to a speed of, that is what we have to find basically, right. So it has moved 100 meters, right. So maybe let's say over here it has moved 100 meters. So what will be the speed of the train here? We are supposed to find v, right. We can use second equation of motion. So we can write here using, sorry, first equation of motion, I am absolutely wrong. First equation of motion, we can write here v is equals to u plus at, and v we need to find, so is it's v only, u will be 0, a is 2 from the question, and t is 10 seconds. It's a very easy question. This is 2 into 10, that is 20, and the unit will be meter per second. So that is the speed, and for those who want to understand what is the speed, you can even convert it into kilometer per hour, but not required in this question. This will be 72 kilometer per hour. Okay, so the train actually started from speed 0 and got up to 72 kilometer per hour in 10 seconds. Okay, now that's the solution for question number 3. We are done. Now let us see the solution of question number 4. This is done already. Let us move to question number 4, which is the graph. I love questions based on graph, and I hope you too enjoy solving questions here. The question number 4 says, the graph given below shows the variation of velocity of an object with time. So here we have got a velocity time graph, right? Velocity is taken in the y-axis, and in x it's time taken over here. What is the acceleration of the object in first 2 seconds? So in first 2 seconds means from 0 to 2 we are supposed to find the acceleration of the object. Well, again in this video I am not going to use any graphical method. We will be using the algebraic method, and we know the formula to find acceleration is a is equals to v minus u by t. So we will be using the same formula. Okay, so we need to find what is u, v and t. So let us write over here for solution 1, we have to find what is u and then v and time t, and then we can put that in the formula to get the answer. So you see basically over here that the velocity of the object starting from 0 becomes 2, then becomes 4, and then becomes 6, and then becomes 8 in 2 seconds, right? So if I take this u is equals to 0 as the initial and v is equals to 8 as the final, we will be able to solve it. So u is 0, v is 8 meter per second, and time it takes is 2 seconds. So I can mention over here 2 seconds, and then we can directly put that in the question over here, formula over here. So v is 8, u is 0, and time it takes is 2. So very easy it is, but take care of the units. This is meter per second and this is 2 seconds. Often children while writing the answer they make mistake in writing units, and I'm a very strict teacher and I'll cut half marks for writing the units incorrectly. So you have to take care of the units also. This is 8 by 2, that is 4, and this is meter per second square. Often children sometimes they write like this, meter per second and minus 2. Well, this is wrong. Either you write here like meter s to the power minus 2 or like this, otherwise this is wrong. Okay. Now coming to the next question number 2, that is for how long, means we have to find for how much time does the object move with constant velocity. Here you have just seen in the previous video also, as the object is going from 0 second to 2 second, the velocity is increasing, right? 2, 4, 6, 8, and then it remains 8, 8, 8, 8, 8, 8, 8, and then again starts slowing down like 8, 6, 4, 2. So this is the region where the object is moving with constant velocity. Constant velocity. So question comes for how long? It is going from 2 to 4, the object is at constant speed. It means that the duration will be like time duration will be 2 seconds, because this is 4 minus 2, or you can write for 2 seconds, or from 2 seconds to 4 seconds. You can write the answer in any form. Okay, so that's the solution of question number 4. I hope you're not tired solving these all 4 questions and you're feeling fresh. If not, take a break right now and enjoy. Okay, so that's all for today's video. We'll see you in the next video. Till then, take care of yourself, keep learning, keep watching and keep growing. Thank you. Bye bye. Take care.